Hi, it's Chris with Revenge Performance again. We are doing some Haltech tuning today on a 94 twin turbo 13T car. It has front mount air cooler, some 550cc injectors, and we recently did a complete Haltech with engine wiring harness. We rewired the engine harness from scratch, so this is all new wiring, all new plugs. And we've got the car driving around, and so now we're starting to do a little bit of power pulls. It still needs a lot of work in the tune, and that's what we were kind of showing you how to go about that. And so let's start with the most accurate power pulls, which are going to be in third gear. First of all, we did some baby pulls yesterday to verify that the fueling was safe. It's really rich, as you're going to see, particularly at higher RPM. It's been, well, I don't know if I've ever tuned a Haltech on a stock cam TD04 setup. And so you're always going to see a lot of volumetric efficiency drop off as you start to get away from peak torque. And basically, once you start getting over 4,500, 5,000 RPM, your VE curve is going to be dropping pretty drastically on a stock cam car with a small turbo like this. So, but yeah, they can make a lot. They can make good power. It's just you have to consider your power curve is going to drop off a lot kind of after 5,000. And there's some things you can do. You can actually run more boost at higher RPM than at lower, stuff like that. But we want to get the car safe first and pulling cleanly. And believe it or not, even at this incredibly rich indicated AFR, we are pulling cleanly. And there's a lot of drivability issues right now as well. You can see here when we're first engaging the clutch and things, we have a lot of AFR work to do. But it's drivable, and I like to kind of dial in some sweeps here because once you've got the car to where you're cruising at 2,000 RPM or whatever, and good AFRs and things like that, and you're watching the AFRs as you do a pull, you can start to tune some power pulls. And the good news is the engine is loaded up enough that it's a steady state for this pull here. You can see here we basically took off in first, and I was only going to do a second gear pull, but it felt pretty good, so we grabbed third. And you can see here I probably didn't let the clutch out fast enough, slipped a little bit there. But we have a nice pull from third gear from 4,700 to 6,400, 6,600. So this is the area I'm going to trust the most. Your second gear pulls, particularly when you're running an advanced ECU like this with high-speed data logging, and it's got CAN bus dual widebands on it, you can trust some of your second gear to kind of get you where you need to go, but the real truth is going to be some of the higher gears where the car's under more load, and the time frame between when the events in the engine are occurring and the actual wideband reading is occurring is drawn out a little bit in higher gears, and so you have a little bit more confidence in this. So I'm going to use information from the second gear pull to make judgments on what's changed here, but I'm going to start with the third gear pull and make sure that the curve is kind of making sense compared to what second gear is showing. And I think it will, but again, I just trust the third gear a little bit better. So I'm going to start kind of at the top. I usually would start at the bottom, but since this is only a partial third gear pull, I'm going to kind of start at the top. You can see here it's really rich. So we are using some short-term fuel trims to keep things safe while we're kind of doing a pull and not staring at the laptop. But you can see that's removing 10%, and we're still very rich. I don't know if I would consider these accurate at this rich a level here. So one of the keys here is not to take this information and go and take 30% out of your fuel map, because this may be indicating 7.5, I don't think it can read that rich in real life. So this could be 9.5, and so if you pull 30% out, you could be in the 13s. We'll just have to see. I like to take things a little bit slower. So right now the ECU is pulling 10% out. So I'm pretty comfortable pulling 15% out of the tune. But there's a couple of things to consider, and we'll show you when we get into the Haltech software. First of all, I want to say I do have a lot of experience tuning Haltechs, but I'm not going to consider myself a guru on them. They Some of the modifiers still trip me up every once in a while, and so if somebody's got better ways to do things, then more power to them. I'm just giving a practical example of how we're going to tune this car, and I think the results are going to be good with our methods. So again, we need to look at a couple things when we're reviewing any kind of logs here. First of all, we want to look at our knock count. We haven't really calibrated the knock sensor on this car yet. It's running such low boost that these are actually pretty good calibration noise runs. And so we can review the voltage on the knock sensor and the dB and things that we're actually hitting. And we could consider this to kind of be the floor for quiet operation of this engine. Even at red line with some possible boost creep, we're kind of running on wastegate right now, so we're running about 10 pounds. So with 93 octane, 10 pounds, and 20 degrees of ignition timing, we definitely should not be seeing any knock unless there's something mechanically wrong with the engine. So this is actually establishing some pretty good knock floors for when we do start to turn the boost up. If the motor gets a lot louder in certain areas, then we can consider that to be actual knock and take adjustments as necessary. For this car, eventually he wants to go to a flex fuel setup. And so, just like I tune most stuff, we're probably going to end up at 15 or 16 pounds. I'm not going to push this up to like 20 on pump gas because he wants something fun that he can take on drives and not have to worry every second if it's going to start knocking or something like that, detonation. So, but we'll get there. But we start at low boost, keep things safe. So we're going to pull a bunch of fuel out at 6,600 RPM. And we can also tell that we are at 10 PSI of load. And that'll tell us kind of where to go on the map. Haltech also has a feature where you can follow your basically all of this inside the calibration. And you can see exactly what the calibration was doing and what cells they were in and stuff like that. That can be really useful for some debugging, and that could be a good way people like to do it, but I like using the data log viewer because we can get a lot bigger picture of kind of what's going on. I mean, just literally. So there may be better ways to zoom in on the timeline in the Haltech software, and I would really like to see that because for me, it's really hard to kind of see what's going on because the entire timeline is stretched out there. So let me see if I can get OBS to record this area of the screen because we're going to be switching back and forth between the Haltech software, the NSP, and the data log viewer here. Okay, you should be seeing our Haltech NSP software. Nicely of Haltech, they updated the Elite Series ECUs to be able to use the Nexus Series software. Really great because the software looks a lot more modern and it's easier to find things and it connects way faster. So you can connect in just moments to the ECU where it used to take, I thought it was like 30, 40 seconds it would take to hook up to the ECU. It's a lot faster. So when I'm working on fuel tuning, I want to look at just the base fuel tuning, and also we got a table here, but we also have a 3D graph, which is pointing out that this is really rough. We are going to smooth all this so that there's some gradual transitions and things like that. You shouldn't really see a whole lot of lumps like you're seeing right here. But there is kind of a couple of spots in these cars when they got stock intakes and things where they tend to want more fuel. You just have to make sure that you're not transitioning between different areas. Like this hole here we have needs to be addressed. And we just don't have data for that yet. But once we get this a little more dialed in and closer to what we want, we'll go back and do some vertical and horizontal interpolation between different areas. And we can infer a lot about what the map wants based on kind of how it starts to take shape. So you don't have to have, every single cell actually in a pull to determine kind of what to do. So as we recalled, um, our data log here, let's switch back to that little guy. So we can see back in our data log viewer, we are running in the zone of 10.5 pounds, and we're running at 6,640 RPM, and we are extremely rich. So we're going to pour a lot of fuel out of this thing here. So back in our Haltech software, we can go look for about 10.5 pounds boost. You're going to find that your columns here don't necessarily match what you're being logged, and so it's going to interpolate between these two columns. So what I kind of like to do, particularly when we're getting started out here, is this car is trying to run 10.5, so I'm actually going to change my table axis, and I'm just going to change this 11.6 to 10.5, and that actually moved this cell up, and that's fine. Just kind of make sure that it's not doing anything funky when you're changing some of these columns, like putting in values that you don't want. But we got plenty of resolution here. Like I said, this car is probably not going to see much north of 17 pounds for a long time. But even if it does, we have information on the map here. So we were looking at 6,600 RPM here. So right in this region here, it is extremely rich. So kind of what I like to do is look at actual data points I have and set them, and then go back and connect the dots, basically by smoothing things out. I do want to also mention this car does have fuel trims enabled for wideband feedback. And so you want to look at your bank 1 and bank 2 if you have it, your wideband feedback, to make sure there's not fuel being added or removed in the areas you're trying to adjust, or obviously that's going to cause a problem. You can apply these to the base table as well if you want to do that, and then go in and smooth it. I don't like relying on this a ton. It's kind of necessary at low loads. You're going to see some movement around here, particularly as the car experiences weather changes and just driving conditions, gets heat soaked, stuff like that. That's fine, okay? You can chase this for a while and try to get that to plus or minus 5, and you probably will, but that's not scary at all for me. But if you see like 22% here, that's a huge problem, okay? Especially if that's just a single cell, and maybe this is minus 10. I mean, I've seen some tunes like that, and it's like this car is depending heavily on wideband feedback to not blow up, and that's really just asking for trouble. And also having a really rough transition like this, especially if I've seen adjacent cells like that, and so what it's doing is interpolating between these two. Depending on where you're at, you're not going to have a whole much of a clue of what it's actually going to do. I guess this is fine if you want to tune this way at first, but you definitely need to roll this into your main table and clear this table back to 0 by the time you're done. I really don't like to see this stuff. It's super dangerous. If the car ECU ever gets reset, it's going to forget everything it knows. If you have any kind of problem, it's just going to make it worse. So try not to do this. If your tuner did stuff like this, and this is what your wideband feedback table looks like, then they probably didn't tune your AFR. So sorry if they did that. Takes time, but it's worth it. So closer you can get these to 0, the better. And keep in mind there are 2 on this car. You can see here it's adding a pretty significant amount of fuel to the bank 2, and that's about where it idles. It's minus 17.7 here on the stock cams. But the front bank is actually subtracting some fuel. You're going to see that at idle. It's just the nature of the fuel distribution or the air distribution on these cars. They just seem to do that. You also got very different exhaust manifold designs, front and rear, on these, and I'm sure all of that contributes to that. But it's okay. Okay, if these are apart, that's fine. And like I said, you could tweak this and get this down to 5, and then maybe this is minus 5, and we will. It's just for starting out, the car idles and drives around, this is fine. Don't worry about that. You just don't want to see that at high loads. By the time you're getting to high loads, your front and rear bank should be within like 5%. They should be a lot closer than they are at low loads. So I suspect it's an airflow issue in the stock manifold. I don't have proof of that, but that's kind of what it acts like. And you could read your spark plugs if you just let the car idle and kind of sort of pick up on that too. But that's also why I really like to have dual widebands when you can do it. If you got an ECU that supports trims, because you could have the front bank running 13-1 and the back's running 10, and the average looks great, but it's not great for the motor. It's not great what's happening. And I know studies have put 8 widebands or 6 widebands in a car, and there's more variance than you would hope for. But still, we're trying to get the most data possible, and at least we know front and rear kind of what the differences are going to be. So back to the base tuning. We have a data point at 6,500 and 10.5 now, and this was super, super, super rich. So we're going to put our P button here. I know I could do things quicker, but I'm rarely comfortable making a swing greater than 10%. So let's do that. And I know that's not going to get the fueling where it needs to be, but it's going to let me feel safe to go do a pull and not hurt the car, okay? And this is really low boost. You could probably run 12.5 to 1 AFR and it wouldn't blow up like this. I wouldn't recommend it, but let's just not take our chances. We're very cautious with customers' equipment. I'm very cautious with my own stuff. It's sure a lot easier to spend a little more time tuning a car than it is to be taking the engine apart, sort of thing. So we're going to go ahead and hit the P button, which brings up our percentage change, and we're going to do -10. So, and that will be changed there. You can see right there, you can see the hole in our fuel map if you look at the graph. We don't want to leave it like that. Like I said, basically the approach that I do, wrong or right, is I'm going to go through and grab all the data points I have and then kind of start to connect the dots using smoothing, and that works pretty well. So if we go back and we look at our data log viewer, we can hop down to 6,000, and you can see here at 6,000, it's still really rich, but it's a lot better, okay? And so this tells me, taking 10% out of that would get it pretty close. And that's not unusual. So at 6,000, you'll go look at all these cars with stock cams and such. They roll over at 6,000. It's kind of what they do. So it's going to demand less fuel. That's expected. We do also see we're only running about 9.7 right now. The boost control on this needs some tuning as well, but it's probably close enough to our 10.5. We can deal with that. So this short-term fuel trim is also pulling 10% still. So I'm going to go ahead and pull another 10% out of 6,010. And yes, I know that means at 6,500, it's probably still going to be richer than we hope, but we're just going slow. So back into Haltech, we're going to go down to the next cell, 6,000. And obviously this motor doesn't need to spin to 10,000, okay? In fact, let's just go ahead and fix some of that, because we kind of want more resolution in here if we can get it than we got up here. So let's go to our table axis setup again. And we do not need a 10,000 row, but maybe 6,200 would be nice, 6,250. And maybe 6,750, sure. And I do not think he's ever going to want to spend this thing past 7,500, but we do want some data there. Let's see if there's anywhere else we feel could benefit from some more resolution, because you can also just delete these rows you don't want. I kind of like to, put let's see if this puts us on the correct side. I like to put a row right where it likes to idle. Gives you a little bit of control over that. I mean, that's pretty well, that's a lot of data points. We should be fine. We're going to go ahead and delete the 10,000 and the 9,000. Well, yeah, let's delete the 9,000. We don't need that. So you can see here our chart's been changed a little bit. We're going to want to go back to 6500 and verify that this makes sense, and it does. Because as you start to change these rows, the ECU is going to do the best it can to interpolate, well, the NSP software will, between the rows, but you still need to be cognizant of what it's doing. So we got to go down to, let's go down to 6250 then instead. So if we look at 6250, got a good data point right there at 10 pounds. Again, it's at least 10% ridge. We're targeting 11.4 here, so it's probably 15% ridge. But I'm going to go ahead and pull 10% out of there. Again, we P minus 10. See here, that reduced that 8 points, which, yep, that's 10%. Okay, let's see what it wants at 6,000. Probably similar. So at 6,000, we're kind of getting more in the ballpark. Again, it's short-term fuel trims. You're pulling 10% out. So, it's still pretty far off. So we're going to go ahead and pull another 10% out. 6,000. E minus 10. Got that. And let's go on down to 5750. This is a lot closer. You can see we're about within 10%, but we got that short-term fuel trim going on too. So I'm going to pull another 10% out of here. We do not have row 5700, so we're going to go to 55. And these numbers are making sense. Okay, they're pretty steady, and then they start to roll over. That's kind of what you would expect here. Okay, so let's go down a little further. So we have data at 5200 or so. So the data at 5000 and 5200 is basically the same, but it is starting to not be as rich. You can see, yeah, we're about 10% lean or rich here, but it's only removing 3%. So we're getting a lot closer. So I'm going to be a little extra cautious. Let's pull 8% out of there and see what that does. Because we're getting closer to peak torque. Motor stock cams is going to need more fuel in that area. Okay. Get close to the end of this pull. You don't want to grab right off the edge of a pull because you may be dealing with some acceleration enrichment and things like that. But it looks like our 4500 area is probably going to be the same. We're about 10% lean here, or sorry, rich. It's Friday, okay, guys? So be nice. So we're going to pull 8% off of that again. Oop, went the wrong way. Well, it's good to have that graph open. Minus 8%. Okay. So back to our data log. So our third gear log, we've kind of exhausted the information we can get out of that. Let's look at our second gear. It's super rich, super rich at 7,000 or so. So we're going to pull like 10% out of that. So back up here, you can see above our first modification we made. And we do not have data above this, but predictably the engine is going to continue to roll over. So we're going to go ahead and just pull 10% out of kind of everything after that. But it's kind of party time if we're hitting 8. So I'm just going to bump that up a little bit back. Just a little. Little big guy there, Bob Ross style. Never see that. Just keep it. One thing that making it run a little rich at the red line too is it kind of eases up on things. You kind of want, depending on what you want, if you want a really harsh red line, you wouldn't do that. But I kind of try to take it easy on the motor, and so riching it up and moving some timing as it starts to get really close to the rev limiter kind of make sure you don't bash into it so hard. Okay. Back to this little guy. So let's confirm some of our info. 6,500, yep, super rich in second gear too. About the same actually. So that's good to confirm. Because I would rather do second gear pulls until you get close if you can, because the speed involved in our Mexican testing facility here, we have to be careful. And obviously there's more time and load for things to go wrong in third gear in an engine. So you want to do it in second gear if you're confident your equipment is giving you usable data in second gear, which I'm getting pretty confident that this is. So same thing, 6,000. See around the 5,000 mark. Not as much boost. So at our 8 row here, it's kind of doing similar stuff, but it's not as bad. Probably an effect of the restrictive turbine housing type of thing. You keep running more, it's just a little bit of difference, but as you run more boost, the same turbine housing, it's gonna basically take more effort for the exhaust to get out, and it's going to require less fuel. But it's still pulling 5% out of our short-term fuel trims, and it's still a good 5% lean. So I'm going to take 5% out of the 8 row from pretty much red line down to where we're at now. So now's kind of time. I have a few data points. I kind of feel confident to start making some changes like that. So let's switch back to our Haltech NSP. So in the 8 row here, there's absolutely no reason that this won't be doing similar stuff to this row. It's just not quite as aggressive of a removal of fuel here. So we're going to pull 5% off of here. So that'll get that closer. And that also kind of fix this a little. And we'll go back and we'll fine tune that. Don't worry. So let's look back at our log. So at 4,500, pretty close. Okay, and again, this could be an effect of the gear goes by pretty quick, so we're not going to make big changes here. 4,500 is just a touch rich, but it's pretty close. And you can start to see your lines converging sort of thing here. So let's see what we did at 4,508 pounds. So at 4,508 pounds, we haven't quite been there yet. So I'm going to be real easy on this one and just take 3% out of that. And the odds are the rest of this needs this too, but let's see if we got some more data points. So if we look at, and the closer to this gear change and whatever's wobbling in here we need to fix, the less confident I am in this data, so the less changes I'm going to make. But at 3,500, man, we're pretty much getting there. It's pretty close. Not sure, maybe pulling some fuel out from a previous reading here because it shouldn't be pulling too much out of there. See here, we got some lean on the gear change. You can see that this is all the way down at 2,604 psi, and that's a load point that we haven't got to before. It's really lean, but again, I'm not going to take this as gospel because anytime you see some transitional boost periods and things, the wall wetting of the intake manifold and everything else is going to contribute to some kind of leanness on there, but I think we can do a little better than that. And it may actually help kind of this wobble that we got off of this that doesn't look very good here. So let's kind of find the leanest spot here. So even all the way down, yeah, so we got about 2,300 and minus 5. That kind of needs about 10% more fuel. That is surprising. Again, I'm not sure I believe this exactly, but let's go look at our map here. 2,500 and minus 5. So we'll go down to minus 5 and 2,500. You can see this has already got a little bit of boost, so we're kind of getting, not boost, but higher VE. So this is kind of getting in the area where I said the cars kind of tend to like more fuel in that area. It's just something that kind of these things do. So you can't always trust that, though. It just doesn't seem to run perfectly through that area. You could take a stock car and kind of feel it. Just is a little upset at very low loads and 26, 27, 2,900 RPM. But I'm going to go ahead and to help smooth this transition to boost, I'm going to put a little bit more fuel in these areas here. So let's put in 10% there. At this point, I kind of start smoothing some stuff out so we can hit H to kind of smooth that out. And I would just continue that on kind of with my gut feeling here. you can kind of, like I said, we don't got data for every point here, but we kind of figure out what the car is wanting based on what it's doing in similar areas and kind of hand tune some of these rows. And there's less drivability problems if it's a little bit rich in certain areas than if it's lean. Okay, let's see what else data we have. Well, it was really kind of struggling through here. You can see the AFR is not happy either. Let's see what's causing this. So it's pretty lean right off idle when we're hitting low load. And I could tell this because driving the car around in the parking lot is rough. And the idle's not the stablest yet. And it's also not, you kind of let the clutch up and it wants to struggle. And so that's why it's important to kind of try to find areas like this where it's doing that. If you don't have a load-bearing dyno, a trick that I've done is I'll put the car up on jack stands and let it idle out in first or second gear, and you can kind of adjust how much load you want to put on it with the throttle and the brake, and you can kind of hold it there, and you'll get better data than all this transitory data as things are happening. So we'll probably do that to this car when we get a little further down the road, just to smooth out some of these areas, because we want this to drive like a stock car around parking lots and such, and not be a kind of bucking horse type stuff. So I would say, and again, it's tricky because wideband 1 is a lot closer than wideband 2, so we're kind of going to have to split the difference here. But I want this to be rich, if anything. Okay, this is right around 1,000 RPM and kind of getting some load on the motor. You're not going to care if it's a little rich there, but you will care if it's 16 to 1 and it's trying to misfire. So let's look at -2 and 1,000 RPM. Just here. So we go 1,000 RPM. -2 is kind of in this region, and you can see there is a hole here in the graph. So again, from what we learned in other areas, this makes sense, okay? So you could probably do a little bit of interpolation there, help that out some, but I think it needed a little more than that, right around 1,000 and minus. So I'm going to put about 5% there, 5% there, 5% there, and we could sort of start to fix this area here that looks like crap. Just a little bit more fuel in there. And like I said, we come back and this is too rich, big deal. It's not going to kill it. Ain't going to care. It's going to run just fine. But when they get lean like that, you're loading them up, that's when they try to buck you off the thing. It's not a good thing. So at 0 RPM, this affects your startup a little bit. So it is kind of nice to get this a little bit smoother than it is currently, but it isn't the end of the world. Sorry, again, it's Friday. I'm tired. I'm ready for the weekend too, but I want to tune this car. My energy level seems a little low. That's what's going on. Okay, let's look at this. Okay, that is definitely a little lean. We also want to look at our engine coolant temperature because we did just start this. So I want to make sure that the car is warmed up enough at this point for this to be reasonable data. It's not. Okay. So if you start tuning these before they warm up, you're going to be chasing your tail because you're fighting coolant enrichment. But given this is lean already, I kind of think it still needs a little bit of fuel right there. And so that we're going to do that. So if we go to, this is about -8 in the 1800 range. It's way down here, which kind of makes sense because if you look at the adjacent cells, they're quite low here. So I'm going to go and grab kind of this whole block here, put some fuel in there, and hopefully some of that will start to smooth this car out driving around the lot here. Okay. Okay, so we're back from another second gear pull. It's pretty confident in our second gear pull data earlier, just based off what we were seeing from the comparative to the third gear pull. So I'm just going to do some second gear pulls until we get this a lot closer, and then validate our third gear pull. So kind of let's start at the top again. So we got to 7,000 RPM, and you can see here our AFR is still super rich, but it is coming more into the range of sanity. I think this is a pretty good review of our coil on plug kit that it can fire this without any kind of misfires. But let's get this a lot happier. You can see here our short-term fuel trim is still pulling 10% out. So I'm going to go ahead and pull that 10% out. And then this should be getting up into the mid to high 10s with that additional thing. And then if we validate that it is doing that, we could pull another 10% out type of thing. So let's look at, we're hitting just about the same boost, a little bit lower. It warmed up a little bit today, so you're going to have that when you don't have your boost control dialed in. Let's look at 7,010 pounds. And first of all, like a safe tuner here, let's take a look at the old knock situation, make sure it's still not doing anything like that. Don't know why it would, but let's look at it. So if we look at our knock count here, we still have a maximum of 0, which is good. Again, our knock threshold is not completely tuned, so we'll have to kind of figure out what that wants here eventually, once we start increasing the boost, and if we see some of that, or we may even reduce this threshold until we start to see some getting closer. You know what I mean? So like right now, the base tune is saying that it can accept up to 50 dB here, and I need to find the right channel to see what it actually is. Let's take a look, see if this is it. New, let's see, where is that right now? Knock signal. Yeah. So I got my knock signal pulled up, and you can see here we're way under this floor that Haltech decided. So I'm probably going to tighten this up a lot. Because if the car is that quiet at 10 pounds and this really rich and things like that, we want to kind of put our knock floor above 18, but 50. Probably if the motor gets to 50, this thing's going to be in bad shape. So, maybe we start this at 25 and kind of that way we're a lot closer. And it is per RPM. So you can see here the limit's 43, but our motor's still only making 18 and things. So that's pretty quiet. So we'll have to kind of lower that threshold because I do want to get the knock protection to work on this car. And if your threshold is way higher than the motor's ever going to hit, then you're not going to have any knock protection basically. So now that we kind of got some levels for what the engine sounds like when it's not detonating, it will get a little bit louder as we apply more power, but it shouldn't go from 18 to 50 dB if nothing's wrong. That's for maximum effort build here with 40 pounds boost or something. So let's take a look at, again, we're at red line and 10 psi. Let's look at our latest map that we had before. So we'll go to 7,000 and 10 psi. I do want to note this should start to slowly resemble our torque curve. But other than that, you can't necessarily say your numbers are wrong or right because there's a lot of variables, particularly in the characterization of your fuel injectors. If on your fuel tuning, we got 550 in here for the flow rate, right? If they don't really flow that, then your VE table is going to be affected. Let me think about that for a sec. So if we drop this 10%, the ECU is going to be adding 10% more fuel. And then your VE map's going to alter there too. So you can't necessarily, we want to believe that our published dead times for injectors and our published flow rates are correct and things like that. But there are a number of variables that can impact this. So like I was saying, these exact numbers aren't necessarily that important. Don't get too hung up on it. I think on my car, some things are like 110. And so you're going to see some differences based on the fueling and every other complicated thing involved in combustion. But anyway, but I would normally expect these to be a little bit higher. So I'm curious what the variable that's causing that is right now. But we'll just go with it. So we're going to take out another 10%, minus 10. So we're down to 68. Let's see if that did that. And let's get a look at some of our other data. So we also have data at 6,500. And this is quite a bit closer. So once we take that 10% out, it's almost going to be in the range of the short-term fuel trims. And you can also see that it was getting more towards this cell here. So let's go ahead and take 10% out there. And we'll take 10% out in these two cells that were adjacent, which means that these two cells are likely going to want 10% out too. There we go. Kind of got a little hole there now, but let's see what other data we got. So at 6,000, we're getting much, much, much closer. So again, I'm going to creep up on this a little bit. So let's go to the 6,000 range again, which is down here. And let's take off 5%. Do that. And again, we'll come back and smooth this in a minute. So we look at that. 5,500. You're getting, again, much, much closer. Let's just take like 5% off of that. So 5,508 pounds. Okay, which probably means at 10 pounds it's going to be needing that too. So let's do that. And then go look at our log. Go down to 5,000. And here we're getting quite close. This is almost within the realm of acceptability. It's nice to have the short-term fuel trims removing just a little bit of fuel. It's safer than it's adding a little bit of fuel. But that is 7 pounds and 5,000 RPM. So way down here, we're pretty close, which again makes sense because of kind of the torque curve on this setup. So we're going to go ahead and just take away like 3% there. Go from there. And continue down. So we'll go to 4,500. And 4,500 is pretty much perfect. So we're targeting 12.2. Just fine for this real low boost. And it's only taking out 3%. So I'm kind of inclined to leave that alone. We are at 4,500 RPM though. So now that I consider it, I think I'm going to drop this target AFR just a little bit. Kind of more used to tuning the E85 anyway. But if we look at our target lambda table, this is kind of what we have. So at 4,500 and down in this lower boost range, let's just go ahead and take that down a notch. That was a lot. Don't want that. Sure. And same thing. Let's take this down just a little. And that should be a little bit safer. And then we can kind of look at our map. You also don't want really rough transitions in your fuel map, target AFR map. Nice thing about Haltech is since it's VE, if you get the VE table correct, you can make modifications to this later, and it will be pretty much right usually. So if I wanted to say run 11 to 0 here, you could, and it would just work. So not a big deal. It's pretty nice. Okay. I'm going to drop this a little bit too. Okay. Let's give a little bit more safety factor to everything. Because it'll use a little bit more fuel, but it's not going to cost any power to do this. Okay. Yeah, that should be a little bit more safety factor. Okay, back to our base fuel map, back to our data. And we'll go on down to 4,000, 6 pounds, and we're pretty much spot on. And you can also see our graphs are converging very well here. And you can kind of see where the V starts to fall off, right around 6,000, 5,800. Really starts to fall off there. Okay. I started this pull really low, so we'd have good data in second. So 2,000. That's a little rich, but that don't really concern me too much. 5 pounds and 2,500. Again, it's in the rich zone, but again, that isn't going to hurt a thing. 3,600 and 6 pounds is pretty much perfect. Yeah, so that's pretty good on all that. So if we look back, okay, so we've done a little more smoothing to this map. You can see this low spot is where we have good data currently, and so I've had it ramping a little bit richer as we near higher RPM here in case we ever get to that point. And it's just a safety factor I like to build in. It's quite likely that this is still going to need less fuel here. It's just we don't have much data for that, and I would rather the car run rich as we approach that than not. Kind of got this graph to turn the way I was hoping to show you guys earlier. I'm used to the RPM being starting on the left and going to the right. You can kind of see the curve a little better. But as you start to work your VE map, you'll kind of see your torque curve a little bit here as your engine demand. So down here on the right is an idle, and then in here I think is about 5,000 or 6,000 RPM. Yeah, so that's actually about 3,500, and then it starts going down a little bit, about 4,000. So we probably got a little too much fuel in here, but we'll find out as we do some more testing. And this will slowly start to shape its way into, pretty much what the engine's torque curve is. And so if you had hotter cams, then this region over here would have more fueling, and you would have less down here. Hotter cam car is going to need less idle fuel typically, unless you're targeting a richer than stoic mixture to try to get it to idle nice. So I wanted to, once we've kind of smoothed this map out, and again, it's not perfect, but I'm not going to make it perfect until we do a lot more driving on this, making sure that, smoothing these little dips out won't do any good if we got to come back later and change this, but I just don't want any super jagged edges anywhere in the fuel map. The ECU is fast. It can do whatever. It can go between different cells, but engines don't like it when their AFR or their timing changes drastically from one moment to the next, and so we kind of try to avoid that. And it can also be perceived by drivers as not being smooth if it does that. So the next step before we were to road test this tune, when I make a lot of changes like this, again, the car safety is paramount, and I want to make sure that what we did to this makes sense overall. So what we can do is we can go ahead and compare this to what we previously did. So you can't see because of the modal dialog in this program, but I'm just loading up the tune we had before our last run. And it does this sometimes. I have a very big display on my computer here, and so it's kind of struggles sometimes to size the windows because of the high DPI stuff. Anyway, so what we can do next is we can look at this difference map. And so this is comparing the current map to the previous one. And so what I'm going to do here is just verify that I'm not out to lunch on a bunch of these. Like, 1% where I was smoothing or a couple of percent, okay, not really that important. But like where we're taking out 14% from where we were before, be pretty smart to check and make sure that that still makes sense before doing a ramp pull on the car and finding out it's too lean or something. Kind of the same thing with some of these areas. I was doing a lot of smoothing in here, and so you can see there's some significant changes in some areas, and I want to make sure that that made sense. what we did here. So let's start at the top again. We got 7,000 RPM, and we're still real rich. And we are subtracting 10. Let's go look at what we did to our map. 7,000 RPM, 10 to 8 pounds boost. We are subtracting about 12 to 14. So I think that'll get us in the ballpark. So if we look at that, we minus another 10%. That's going to be up in the tens, plus 4 more percent, 10.5. It's still going to be probably pulling a lot out of the short-term trims, so we'll probably end up pulling a little more than that. But again, I'd like to be conservative and sneak up on things. So let's also go down to 6,000. 6,000 was subtracting about 8%, and you can see how tight the front and rear banks start to get. They get quite a bit tighter when you're at higher loads. That wonkiness at idle kind of goes away. So it was still taking 8% out, and it's still about a point rich, which is almost 10%. So if we go look at 6,000, and I don't know if I have boost on here, so let's grab the old engine load map. I'll stick that there. So we still got about 8 pounds and 6,000, and we're still over 10% rich because we're still taking 8% out of our short term. So if we go look at that, 6,008 pounds. Down here, we're pulling about 13%, something like that. So again, totally reasonable. That should get us to where it will run about 11.5 and still be dependent on subtracting some fuel from the short term. So very, very safe until we sneak up on that and get a little bit closer. Okay, so if we go down to 5,500, kind of the same story. It's about 10% rich. The car was subtracting about 6%. We go look at 5,507 pounds in here. We have taken out about 9%. So that's about right. So this is a great way. You can validate a lot of your tune before you actually start driving it. Let's see. So we go down to 5,000 and 7 pounds. We are running almost correct. Okay, our target was 12.1. I think I lowered that just slightly. And so we're really, really close. The car was pulling out about 4%. So you can see on the stock cam small turbo car, it actually starts to lay over pretty good, even at 5,000. So that's, it could, I'm sure it could use more timing above 5,000 with this low boost level. But again, I kind of prefer to raise the boost until the car's happy and then see if it wants more timing before just, putting more timing in at lower boost levels that you may never actually see a whole lot once we kind of got the car tuned for the boost he's going to run around on. So the car was subtracting about 4% at 5,007 pounds. If we go look at 5,007 pounds, we took about 5% out. So given that and it was already a little bit richer than it should be, that should be just about right too. So we go down to 4,500. 4,500 was almost perfect. The car is pulling about 3% out. So if we go look at that, 4,500, we took about 4% out. So that should be just about perfect. So let's move on along. Let's go down to 3,500. We were a little bit rich. Car was pulling about 3%. 3,506 pounds. So we have 6 pounds. And we have 3,500. So we added a little fuel here in our attempt at smoothing. So that's probably wrong. So we're probably going to want to drop that area down a bit. We can do that there. Which probably means this is too. So again, this is why I don't spend a huge amount of time smoothing the map out. Because once you go to look at things, you may find you got to make some changes anyway. You will smooth it out before done though. So once I kind of got that, I'm going to smooth that out a little bit and kind of see if it's happier there. Let's see what impact that just had. I may have put some of that back in. So if we look at 3,506 pounds, we should have been pulling a little bit of fuel out. And 3,506 pounds, we're getting close to zero here. So I'm going to chunk a little bit out of here, a little bit more here. Again, these look pretty drastic changes, but they're not. So I'm just kind of guessing that it's going to behave in a similar way at these lower RPM. Okay. So got a little bit of lump in there, but again, probably going to find it wants something a little bit different once we tune a little bit more in that load area anyway. And these are minor changes. I mean, I'm moving a percent at a time with my keyboard here, so it's very, very, very little. In these higher boost areas we haven't hit yet, I still kind of want to leave some fueling in here. So let's just leave that alone for now. Okay, back down to 3,006 pounds. It was a little bit rich. Car's still pulling a little bit of fuel out. So at 3,006 pounds, we added some fuel through our smoothing. So I'm going to take that back out. And just kind of get its adjacent brethren taken down too. Okay. And again, this is pretty lumpy yet, but it'll be fixed over time. So 3,006 pounds, we're pulling just a little bit of fuel out. So probably there it's going to want some taken out too. Just get that going there. Just like that. Kind of see what's going on there. Get back to our log. We'll go down to 2,500. So 2,505 pounds here is a little bit rich still. Short-term fuel trims had not kicked in yet. There's a little bit of a delay, of course, to help it not try to fight acceleration enrichment. So we should have left that alone or gone a little bit leaner at 2,504 pounds. Get that right screen back up here. So we have 2,504 pounds. We actually added a little bit of fuel. So that's incorrect. Let's take a little bit out. Yep. And I've seen this kind of curve here quite a bit. This kind of does that. They kind of do that right around that 2,900 RPM. They don't act super linear. Okay. Back to this. Almost running out of room here. Somewhere around 2,000, we were a little bit rich too. So 2,002 pounds. So 2,002 pounds. We added a little bit of fuel, so it was already a little bit rich there. So let's fix that. Just take a little bit out and get that going there. It's just the adjacent parts there. Okay. Okay, so that's about the end of our pull. So what I'm going to try to do now is find some. Most of these areas we didn't affect a whole lot, except in the kind of area above 4,500 and higher loads, relatively for what we're doing here. But we did remove some fuel at the lower loads too. I don't know if I hit this in any of my logs yet. So let's just go take a look at our log and see if we can find any of those areas. So we're looking for an area of relatively higher RPM and low load. We just might not have right now, and that's okay. We'll figure that out later. So I'm looking for where my RPM up here in this white trace was a little bit higher, but not under a ton of load. Here's a little bit of an example. So we got 5,700 RPM and 3 pounds. We're actually a little bit lean here, so it would start to add fuel as this kind of went. So let's take a look at 5,503 pounds and what we did. So 5,503 pounds, we did add a little bit of fuel. I don't know if that's enough. It doesn't seem like that's quite enough. So what I'm going to do is add some fuel to its brothers here around it, which will impact it as well, and kind of go from there. So this is why I like to review this. You can solve a lot of these things, you know, just going through the tune on your computer. So let's see what else we got here. We got 5,000 and 1 pound. Pretty significantly lean from what I can tell here. So kind of in the 0 psi area, it's pretty lean, which I'm kind of seeing in some of the cruising parts of the map too. I don't know if I believe that it's that lean because that's pretty far off our target lambda here, but we'll give her some fuel. So around 4,502 pounds, let's figure on giving it at least 5%. It's such a low load and low boost. It really doesn't have to be super rich there, but let's get closer here. So 4,502 pounds. We added 0.8 fueling, which is not going to be enough to do what we need to do here. So I'm going to lump that up a little bit. And again, we want to lump around its neighbors too. And that's probably not a technical term for you guys, but we're lumping, okay? Just trying to keep it smooth. Yeah, so that'll help that a little bit. Okay, what else do we have? 4,003 pounds, again, is pretty lean. Like to give a lot more fuel in that sort of area. 4,003 pounds. So 4,003 pounds, we did add 3%. I don't think that's going to be enough. I'm going to add some to the 3,500 area and then lump that up a little more here. Just that whole kind of block. So that'll take that up. Good percentage. Run a little better there. Okay, and we're in some transitional throttle states, so you do got to be careful here. It's going to lie to you a little bit sometimes. This is just a little bit lean at 3,301 pounds. So what did we do there? So if we look at 3,301 pounds, we did add some fuel, so that'll help there. I don't like that hole right there. Let's boost that a little. See if that's happier. Yeah, we'll smooth this out when we get to that point. Okay, have some faith. Okay, back to our log. That's kind of all I can take out of that. Let's keep going here. Let's just look 4,000 minus 2. This is lean enough to be stuttery, so the 4,000 minus 2 area is very, very, very lean. It needs fixed. It's just not going to run well like that. So if we look at 4,000 minus 2, this is where some of your drivability is going to come into play. So we're adding 2.6. That's just not close to enough. So I'm going to add a bunch to this area like that. So we got a good 6-7% there. Let's go a little more like that. Let's see what we got. Probably need some more here too. Okay. Getting that kind of straightened out a little. So 4,000 minus 2, we're adding almost 8% now. Which, according to this math, it's not going to fix it. But let's see what it does. When they're kind of really off the rails there, especially at super low load, I'm not really worried about it getting hurt there. I don't quite trust it yet, so we'll see what it does. We'll come up on it. Yeah. Okay. Same kind of story. That whole area, 3,800 minus 4 needed some fueling. But again, that could be why this is stuttery right here, because it's just unhappy. Okay. It's just a little bit on the edge of running decent because it's so lean. So if we look at 3,800 minus 3, we added 8 to 9%. So that's going to make a big difference. We'll see what it does. Okay, kind of check some other areas. 4,000 and minus 2, we already looked at that. We got 2,700 and minus 7. And it's a little bit lean around like 2,800 and minus 7. Let's see what we have here. Yeah, so we added about a good 6 or 7% there, so that's probably going to help that. If I can get back to this, there we go. So that's going to help that a lot. And this is an area where, you can run 15 to 1, no problem. It's just you start getting to the 16 and be stuttery. It depends. That's pretty low load, minus 7.6 pounds, so it's like 14 inches of mercury. So it may be okay with that, but I don't want to run it that lean. Oh, that's pretty close. I mean, it's a little rich, maybe. Let's worry about that later. Let's see what we got. This little wobbly part here, 1,100. And again, you can't always take this for gospel. You got to use your common sense here, because we just did a little throttle blip right there, and so that's going to mess with our wideband settings. You're not going to get consistent AFR when it's doing acceleration enrichment. We'll come back to that. I find that when you get the main fuel maps tuned, the Haltech's, the Excel's pretty good. It's not like some older ECUs where you spend half your time working on the Excel. So I actually haven't had to change that a whole lot. A lot of stuff. Okay, that's probably fine. We can kind of look for any places where there's huge gaps here, and what the cause would be for that. Like this is way off. Let's see what we got going on here. It could be under deceleration. Yeah, so our throttle's at idle, so we're probably just coming off the gas, and so it's natural for it to cut fuel. Yeah, just looking for areas where we're actually on the throttle, and it's doing that because we don't want that. You can also kind of look at your short-term fuel trims and see where it stands out to you that there's a problem. Like here, it's adding a bunch of fuel, but again, this is in decel mode. Part of the reason the decel is acting up a little bit on this setup is the speedometer is currently not wired in, and so we can't calculate what gear it's in, and the ECU is currently set up to only do deceleration if you're in second gear or higher. And so once that's resolved, some of that will smooth away. They'll fix some of that. I'm pretty good running this map, and we're good to try this out again, probably next week before I get back to that. But we could do some more load pulls and things and drivability improvements and just keep working it. Car basically ought to run like stock or better once the tune's completed. Kind of gone are the days where if you ran a standalone, you had to accept not OEM type drivability. But when you're building your VE map and everything from scratch, it's going to be time consuming to get to that point. But once we have this developed for like a stock cam car, this would be a good place to start. Well, it's 9 in the morning. It's time to get some more revenge on this ride. So we've been working on this 1994 3000 GT SL twin turbo. And yes, that's a turbo swap car, so they did not come that way from the factory. This car has a mild TD04 upgrade, 13 Ts, and we've been doing some tuning on it. We installed a Haltech Elite 2500 with the dual wideband and all its accessories, and we use the premium universal engine harness to eliminate the factory wiring. Factory wiring by now is getting really old, and it had already been cut up. And the car had a our Revenge coil on plug kit, and it also had turbo, the inline resistors for the low impedance injectors, because it used to be an NA car, and so the wiring harness was kind of a mess, and so we elected to put a whole new harness in it, which is a lot of work, but the benefits are great. You don't have as many OEM wiring problems to worry about. So this morning we did a pull. We're starting to add some boost duty cycle to this car, and it's starting to respond. So let's just take a look at this third gear pull here. And that's our second gear pull. We're looking for, the longer one here. So pretty good pull. We started at 3,000 and got to 6,700 or so, which is plenty for what we need. And as you can see here, it's still a bit rich, but nothing like it used to be. So we're getting much, much closer on the fuel mapping, which again, the power pull fuel mapping is really not that hard, but I do like to approach it carefully, and so it takes several revisions to get there. You can see here we're at least above 10 here, so this is pretty rich yet. We're trying to get to about 11.0 AFR high load like this, and so that's what we're going to do. You can see here we're looking at the short-term fuel trims, and you can see these drop like a rock. Basically, as the car starts to get over 6,000, the fuel demands of a stock cam, basically factory type of turbine housing on the TD04 turbos is seeing their limit, and so it really starts to roll over here, which is why it needs a lot less fuel. So we're going to go ahead and do what I usually do and just start at the top. I am going to consider the 6,700 RPM to just be 7,000 because it's really just going to taper a little bit more, but our results are going to be super similar. You can see here we're hitting 11 pounds boost. We currently have the ECU set to 10, and I've been rolling in some wastegate-based duty cycle to get that closer and closer, and it's starting to pick up boost now, so we're kind of right in the ballpark. So it's overboosting a little bit, but that's pretty easy to correct. There are some boost control tables to look at as well. You can see the target pressure here, some things like that we could display on our second trace. And our target pressure at all speeds is currently 10. Since this is a front-wheel drive car, this is, close to the most boost we're probably going to want to run in first gear. So we're going to do some speed-based boost control on this unit as we go by, but that's, a whole nother package of variables, so it's best to just kind of get it working properly without all that complexity in there anyway. So let's go ahead and look at our short-term boost trim while we're looking at that. You can see here it's adding just a touch. And we're about a pound over, so in the area where it's a pound over, it's not really doing much, taking a little bit out here and there. So luckily we kind of got onto a very close calibration for this boost control solenoid right out of the box. But I'm going to remove just a little bit of duty cycle because, obviously we're probably going to run more than 11, but if we command 10, I want it to make 10. And so since we're so close, it makes sense to take a little bit out of there. But let's look at the fuel tune first. So at 7,000 basically, and you see where I let off. 7,000 basically, we are at 11 pounds boost, and we are still a point rich, okay? And the car is taking out 10% fueling. So what I'm going to do is remove another 10% from this area, and we'll double check the long-term fuel trims to make sure it's not applying any corrections there. But that should give the ECU enough range to get to 11-1, and then we can fiddle with it a little more. It probably needs about 15% less fuel, but again, I don't like to go all that way at once. And I kind of tune these to where the ECU is removing a little bit of fuel anyway. It's just a little bit safer way to go. So let's look at the calibration. Change windows here. Hopefully I'm getting a little better at that with the OBS. So we're going to go ahead and open his calibration. Right there, you can see it's the current date and time, which is good. So we're going to go to our base fuel map right here, which you can see. And we're going to look at 10 to 11 pounds here at red line, right there. And so part of what we're seeing here is we have not tuned any rows above 10, basically. So you can see here, this is a few percent rich anyway. So that is also partially why we're still getting into the rich section. So for this area that's well known, we're going to take out -10 once again, and then we're going to go ahead and blend these right there, which also means at 5, this car is probably wanting less than indicated here. So we're looking at the graph down here too. You can see that lump right there. So I'm just going to hand tune that a little. And that's probably going to be about what we want. And same kind of thing here. There's no reason really for that curve there, so it should behave about like that. Okay, so we've done the 11 row here. For anything above that, we still have no data, but we can kind of guess what it's going to do. But I'm going to go about halfway. So we're going to take away 5% there. So we're still going to have this safety enrichment here if we hit some boosts that we didn't expect. And that makes me feel better as a tuner. If we hit 15 pounds, that turns out it does want more fuel for some reason. Maybe we're running out of fuel pump. We shouldn't be, but you always want to be a little careful there. Okay, so we'll come back and we're going to have to smooth this rough ass transition here. But let's go see if we have enough data to support that. So looking back at the log, if we go down to 6,000, we're actually pretty close. Like I said, this car is rolling over after 6, which is very typical of these type of configurations. I have 272 cams in my car, and ported heads, and bigger valves, and a lot bigger turbochargers, and it doesn't do this as bad, but stock type of setups will roll over pretty bad. So we're still at 11 pounds. We are very, very close to what we're looking for here. Let's see. Yeah, 6,510 pounds. I believe we feathered in already. No, we did not. So we do. Sorry, I got ahead of myself here. We do need to take some fueling out of there as well. We'll just work our way down. Let's go look at the log. So 6,500. We're at least 7% rich. You see the ECU is pulling that, but it's also richer than target. Let's go ahead and pull 7% out of there and try to get this closer to 0 and give this ECU some room to adjust that. So if we look at this little guy here, we're going to go ahead and out of these 4 cells, we're going to remove about 5%. Get us a little closer. Oh, I think I added 5%. Got to watch that. Minus 5%. There we go. And as we would expect, tapers off here as we go higher in RPM. So that's kind of what you'd expect. So I expect we're going to be removing fuel from a lot of these areas, but not as much because the way, again, the car's rolling over. So it's just how they work. So if we look at our log again, we can go down to 6,000. You can see at 6,000, we're very nearly on target. The car is taking 3% out yet, and we're still a little bit rich. So I'm going to go ahead and pull that 3% out as well. So at 10 pounds and 6,000. So if we look at our log, our NSP again, we have our 10 pound and 6,200 and 6,000 rows here. So I'm going to go ahead and take away, let's say 4%. Make me feel pretty good there. And let's go look at our log for some more good data. So we'll come on down to 5,500. 5,500, I mean, it's right there. It's a little bit rich. ECU's pulling 2%. I'm going to leave that alone. It's fine. If we go down to 5,000, same story. This is even closer. We're right at our target lambda. And we also are barely removing any fuel, so I would leave that alone. 4,500, same story. Very good. 4,000, we're a little rich, okay. So you can see here we're targeting 11.6 and we're hitting 11.3 and it's removing 3%. I'm okay pulling about 2% out there. So let's go look at 4,000 and in the 8.8 row here. So we'll go back to NSP down to 4,000 right there, which makes sense because these numbers are a little bit bigger. You can see the high spot in the map here too. So I'm going to assume kind of all of this needs a little bit out of it. Take away 3%. And then we will go down to that low spot we just made. And we're going to do some vertical interpolation on that. So that's closer. Very good. Let's go look for some more data. And we're going to go down further. So 3,500, again, it's pretty close. It's a little rich, not serious. Don't run great route like that. But let's look at 3,508 pounds on the NSP calibration. So 3,508 pounds is kind of right there. And I mean, it's so close, I'm not really even worried about it. Okay. Let's go look at our log. So that's pretty good. Let's look for any wacky spots overall. See here, we must be under deceleration here or something. Let's look at our TPS. Yep, 0%. And you can determine that too if you want. So you can go to our decel cut state. And you can see our highest point is 1 here. So like right there is 1. And here it's getting back onto the fueling. So let's look at some other spots. Okay, I'm looking for short-term fuel trims right down here. Let's get rid of our decel state so I can see a little better. So I definitely am looking for any short-term fuel states that are adding a lot of fuel that are not in decel. So let's see what this is right there. ECU is adding about 10% at 2,500 and -8. This is kind of that rough spot I said tends to exist in these calibrations. So it is looking for a little more fuel here, but if you go overboard and really try to give it everything that it's calling for, sometimes they end up a little rich. Let's see, so 2,600 and -8. Yeah, see, like you can see, it's not always doing that. So I'm curious what's going on with that. But we might have to dig a little bit deeper before we make any big changes. You can't feel this driving around, but it is a little bit weird. So we'll have to work a little bit on that later. See what's going on with this minus part. Very little. It's actually 1%. So the way the scaling looks right now, it looks like a lot, but it's not. Okay. Yeah. So, I mean, this is pretty workable. Let's look at the knock noise. So we got our knock 1 count first. And again, we have 0, kind of to be expected. But let's look at the signal. So we'll look at the signal during our pull. And again, it's still only getting to about 18.8 dB here. So let's go work on that. I've been talking about that a little bit. Let's go look at the knock floor settings. So if we go to knock, we can look at our knock threshold here. So we got our throttle position versus RPM. You can see here, we're kind of way over what this needs to be. This is only looking for 18. I don't want to ruin the curve of this just yet. So let's just go ahead and take away 50% on that, and then we should see some pretty good results just from that, because that's still well above the current knock noise level, but close enough that if we do run into some knock, it should trigger that. Check the trims on that, make sure it's not doing anything, which it's not. And I also wanted to check the O2 control long-term fuel gain trims. See here, we're moving a little bit of idle, but kind of up top, it's not really doing anything. So we're good on that for now. Okay, so let's take a look at this map. We can see it's getting pretty lumpy. So let's see if we can fix that. So again, kind of based off the info, we have to make some assumptions about some rows we haven't hit yet. But this drop off is going to happen, based off, like we keep saying, the camshaft stuff. But we need to smooth this transition a little bit. So do that, and then we'll come down here. Let's get a little bit better with that. Get rid of this hole here. Just kind of hand smoothing that out. We don't want any abrupt changes in our map, because engines don't like that. Okay? And yes, we may find we need to make a few more adjustments later. That's okay. Okay, that's looking a lot better. And we've got a kind of a pretty big lump right here at 3,000 that's probably not needed. And I'll just kind of move some of that out. Too much. And these are relatively small amounts that I'm actually changing here to be safe and everything. Just trying to get this to be a little smoother here. Okay. Here. Okay. We're getting a little better. Span tune some of that. Okay. Just a little bit here and there. And there's not much reason to believe that this lump needs to be here. It does tend to do that because of that lean spot we develop in this region here. So it doesn't always look pretty, but sometimes you do have to give the car what it wants. Okay. And we'll continue to refine this as time goes by and make this smoother and smoother and smoother. But that should be a pretty good start. Okay. Let's go look at our boost control real quick. So if we look at functions, boost control, target pressure, target 10 like we said, we're going to go ahead and we're about 20% duty cycle here. If we look, see here, we're only running 8 pounds at 3,300. So at lower levels, you have a little less creep type of situation. It needs a little more duty cycle. These 13Ts should be able to hit 10 pounds by 3,300, no problem. So this is a tune issue. So at lower RPM, we're going to go ahead and switch this, get a little more duty cycle out of that. Sorry, I think I wasn't showing my window here. We're looking at this boost curve, and so it's a little bit lower RPM. By 4,000, we're a little bit less low. So we need to add some duty cycle there. And by 4,500, we're very, very close to target. So that's probably good by then. So that should give us a little more boost here and there. And yeah, so now we're kind of ready to do another pull and see what it did with our changes and if it likes them all. See what we got here. Want to add my knock here as well. Knock control count. Still have 0. We want the signal as well. And the car's not getting any louder than it was. And I don't see any curious spikes in here. So I think we're pretty good on that yet. So let's take a look at the AFR. So we pulled all the way to 7,000 this time. And we want to make sure we don't clip the decel and mess up what we're trying to read here. You can see here it's still quite rich. We are hitting some load that we have not before, which is why that's probably so rich. This is pulling 10% out, and we're still significantly rich. Again, in the interest of taking things carefully, I'm going to pull 10% out of this area. So we're at 7,013 pounds right now. I'm also targeting 14 pounds, so our duty cycle is just a little bit low for that, but we're pretty close. So let's go look at NSP. So we're in the Nexus programmer here. We don't have a row directly at 13, but we have one very close here at 14. We're going to consider this close enough. So it's 7,000 here. I want to get my graph up. It means it's likely doing the same thing at higher RPM, probably worse. So we're going to pull 10% off of that. We're going to go to 6,700 here. So we have a 6,600. We have a 6,700. You can see here it is also still 10% rich. See right there. Back to NSP. So same thing. We're going to pull 10% fueling out here. Back to our log. We'll go down to 6,500. Sure. And we're closer here, but it is still quite rich. And it's still pulling 10%. So 6,514, we're going to pull another 10%. Yeah. Now let's go down to 6,000. At 6,000, we're much, much, much closer here. The car is still pulling 8% out right there, but it's not pegged, and it's pretty close here. So we're going to pull 8% out at 6,000 RPM and about 13 pounds boost. So that would be this area here. Let's take 8% out there. Yep. Let's go see if we get any more useful data. So at 5,500, we're running about 12 pounds of boost. Probably need to add a little more duty cycle to this full area for the boost controller. But we are actually much, much closer here. I'm only going to pull about 5% of that area. So at 5,500, we're going to pull out 5%. Back to our log. And we'll pull down to 5,000. And you see here, we're much, much closer again. I think I'm just going to pull about 5% out at 5,011. So we're at 5,011 here. Down to 4,500. We're really close. ECU's pulling out 5% to get close to that. We're still a little bit rich. I'm going to pull about 3% out at 4,511. So we're really sneaking up on that. 4,511 minus 3%. pretty close there. Okay. Back to our log. And we'll be looking at 4,010 pounds. We are just a little bit rich, so I'm going to pull about 3 or 4% out of that. Over here. Okay. And then we're down to 4,500, which is 8 pounds. This car takes a little bit to spool, so I'm wondering if the wastegates are a little bit loose, or if we do have a boost leak we need to check a little more thoroughly for. But we're doing okay. So we are targeting 11.9. We're hitting 11.2. It's removing 3%. I'm just going to remove another 3% at 3,508. So 3,508, 3%. Back to our log. And we start all the way down 3,000 RPM at 8 pounds. And we're actually pretty perfect here. You can see here it's not even doing any short-term fuel trims, and we're virtually identical to what we're looking for. So that's pretty good. So let's go back to NSP. So we're looking at NSP here. First thing I want to do while I'm thinking about it is go to boost control. So our target pressure is 14. We're hitting about 13.5. So our base duty cycle is a little bit low. Let's take a gander and make sure that it's not adding a bunch already. Boost control. Short-term trim. It is in fact adding a ton to make that. So that's why we check that. So rather than being just a little bit low, this is actually pretty significantly low. See at the beginning of this pull, it's not actually trying to add anything yet. But once it does, it ramps up very quickly. So at 7,000 hit 13 pounds, we're looking at about 15 extra percent duty cycle. So if we look at our target here, we're at 7 pounds. We're trying to hit 14. We're at 20. So that makes sense. I mean, that's pretty low. I've seen these Mac Boost Solids start to work really well around like 40. So again, we don't want to jump right to what we need just because I'm being a little cautious here. But let's go ahead and make this 30. And then I'm going to go ahead and make this like 28. It needs it, I think. Same thing here. I'm going to add some bit to that just to get that stuff a little bit closer. Let's take a look at our log again. See where it's not adding anything around 3,300. We're significantly off the mark. So let's go back to our 3,300. This is kind of something important to do in third gear because it loads the turbo up the best. So I actually suspect this is going to need to be higher. Just set this to 30 across the board for now. Yep. We'll see what that does. As far as boost goes, make sure we don't have any long-term trims yet. We do have a little bit. So I'm going to go ahead and zero this back out. We made changes to the base table. I don't want to apply both changes. But as you can see, if you kept doing pulls over and over, it would learn and it would get where it needs to be. But you still need to tune your base duty cycles here and get that correct. So I'm going to go ahead and guess this needs to be a little higher too. Okay, now we are getting pretty close on some of the fueling. We need to work on this map a little bit. It's just a mess like that you can see. So first of all, we can determine that this is likely too much. based on what we're seeing at lower boost. It's only going to get less efficient as the boost goes up on this turbo setup. So we're going to do that. I'm going to pull a little bit out of here because we knew we were being very conservative on all of that stuff. That. And we want to kind of pay attention to this. Needs to go down here like that. And that's about as much data as I'm confident in just yet. So tune that up a little bit. Same thing, RPM wise. You can do some vertical interpolation here to smooth that out. Just kind of want to watch that it didn't undo what we're trying to do here. Computer's a little laggy today. Sure what's got into it. Okay. So this is our 5,000 row. See here, 4,500 row. We got a rough transition here, but it does want more fuel at that type of area. So I'm just going to gently massage that a little bit, smooth that out. Same thing with this lump here. Don't really expect that to actually be a thing. And we'll just keep going through here, smoothing things based on the data that we currently have. And that will help the car's drivability tremendously. Okay. So that would actually get the car pretty close to what we were hoping for. Just sort of fine-tuning a little bit of this right now, just to make myself a little happier with the curve here. And again, it's definitely not perfect yet, but we'll get there. We can infer that the car is going to want less fuel up here, but we don't want to assume 100% that that's going to happen. And this probably shouldn't be so lumpy. Get more fuel there. That out. Yep. Mm-hmm. Still quite lumpy in a couple of spots here. Just hand tuning this a little bit. Just trying to make gentle transitions. Because that's probably what the engine wants. In those areas, you just don't have enough data to support it perfectly. Okay. And yeah, the car's just going to need a lot of driving to sort of hit a lot of these loads. The nice thing is, since we got our wide open safe, perhaps still a little rich, it's safe. We got our boost control safe, added some duty cycle to that so that that actually tries to make the target boost that we want. Well, the car does have long-term trims on a lot of things, including our O2 control, as we've talked about. So you can see here, we want to check this. You can see it's pulling a little bit of fuel out up top here. So I want to zero that out since we made changes to the main map. But the customer will be able to drive this car at his pleasure, and this map will populate. Then he'll send us the tune or bring the car, and we will start to apply these base corrections where they need to be in the map. That's how it's supposed to work. But that's the nice thing about having long-term fuel trims. A lot of the ECUs that were older did not have long-term fuel trims, and so you're having to look at logs every time. But really, he can just drive this thing, a whole weekend. And we're going to have a lot of good data as far as what it wants in certain load areas that are not hit commonly, because actual driving is going to encounter different areas of the map than we are able to get in just a couple of pulls. Some cruising. Yep, I know it's still not pretty, but we'll keep getting it there. And we'll get back to you. I'm just going to keep smoothing a little bit of this. Making sure there's not any harsh transitions anywhere. And as we accumulate more data, this map will continue to get better and better. But you can sort of see the torque curve hump here, the stock set, and that's kind of to be expected. That's too much. Okay, so we've made a lot of changes to this map. I want to validate that this still makes sense. So let's go ahead and compare this. We're going to compare this to the previous map. So I want to see what we've taken away or added. Yeah, kind of like what we expected. We've basically taken away 10% more fueling in a lot of the higher load areas. In areas this engine is likely to encounter, we're taking away 7 or 8%, which is kind of the target what we needed to be. And where we did some smoothing, we added a little bit here and there, but nothing drastic. So if we look at our data log here, at 7,013 pounds, we were probably 15-20% rich, and 7,015 pounds, we have removed 10% fueling. So it's definitely in the right direction. And again, I don't like to go and take away 15% just off the bat. For one thing, you want to make sure that your widebands aren't lying. It wouldn't be a bad idea to look at spark plugs. But since we're sneaking up on it, you can always make sure the engine's still happy. If your gauges aren't telling you what it should be, you take away 20% fuel here, and the engine's actually linear at once, you better sneak up on it and find that out and find it all at once. Okay, so let's look at 6,500. Same story, not as bad. You need to pull about 10% fueling in. So at 6,500, we are pulling about 8% fuel out. So that's going to be pretty close to that. Marching on down, let's look at 6,000. It's the same situation, a little bit less. So that's 6,012 pounds. We are pulling out 7%, which is just about what we want. So we'll go down to 5,500. Much closer here. So we'll probably want to pull about 5 or 6% out of that. So 5,500, we are pulling about 5% out, so that's good. At 5,000, you can see we are pretty close on the AFR. Short-term fuel temps are still pulling 6% out. And at 5,000, we remove 3%. So that should get our short-term fuel temps a little bit closer. Not affect the AFR any more than we want. Now we'll go down to 4,500. We're seeing pretty dang close here. Short-term fuel trims are 5% minus. So at 4,500, we are taking away about 2%. So that'll help with that a little bit. And so on and so forth. We go down to 4,000, just a little rich. It's taking 5% out. We look at our map. 4,000, we're pulling about 2% out. Probably isn't enough, but it's getting in the right direction. And then at 3,500, we're in a very safe AFR range, but it's a little bit richer than I want. So let's see what we did at 3,500. Took out 3%. It's good. And we have 3,000. That's actually slightly lean, but we're also tipping into the throttle here a little bit. Anytime your boost is changing like this, you're going to have some wall wetting stuff going on. So you kind of want to stay away from trusting that too much. That's why I try to start the pulls low. So we have a continuous pull here. See here. So that is super, super close. So at 3,009 pounds, we shouldn't have done much. So 3,009 pounds, we took a little bit out just to do some smoothing, but that is not going to hurt a thing. Because if we look at our data log here, We are, in fact, just pretty close. It's going to be really, really close. We're going to be fine. So that's about the power pulls on this. We added some duty cycle. It needs a couple of more pulls to validate this. Going to give the car a break today and get back out working on some transmissions and some customer service. But I hope this has been entertaining. I know this is long. I tried to edit it down. Sometimes I'm a little jumping around. It's just the way I think. But I hope you learned something from this. We do offer Haltech tuning. I will start to do remote tuning as time goes on. It's not our specialty, but when you start working on cars, people need everything from you, and so we try to accommodate. I'm going to continue to look at this log and see here kind of anytime your target lambda deviates from what it's really doing, kind of needs some attention. And, here it's rich, okay, which isn't necessarily going to cause any drivability issues at 12 to 1, but it's some stuff that can be addressed over time. So, again, don't fixate that, oh, well, I'm running 13.4 here, it's not what I want. Well, yeah, you can fix that, but are you really going to notice? Probably not. We do that as part of the tuning process, but it's just not the first thing I focus on. I like to get the car to idle, I like to get the car to cruise, I like to get it to rev freely, and then do some power pulls at low boost and just keep adding more boost so we kind of reach what the customer's wanting to run or what the engine's happy with. As quiet as this motor is, sure, it can handle more boost, and we probably will add a little more boost, but we want to dial in that boost control a little better, because if we ask for more boost and we add a bunch of base duty cycle, we may overshoot. And on pump gas, I would rather not overshoot by much. One other thing I want to do is this car needs speed-based boost control. Ideally, gear-based boost control, okay, which we're going to do, but we haven't set up the gear detection yet. We have to do some driving to get that right. So I'm just going to do some speed-based boost control for now. This car's front-wheel drive, and so it's going to be a handful trying to run 14 pounds in first gear. So let's do our table axis setup here. We can enable another axis here. Coolant temperature is actually a pretty good one. But let's do speed, vehicle speed. Okay, and so we're gonna, start at 0 probably, and then, let's say he's having a great day. Okay, set some values. Let's do the wizard here, make it a little quicker. I want to go from 0 to 200 in sure, let's do 10-mile-an-hour increments. Yep. Now it's going to add the access to this. That's one of the views about the Haltech. So we're going to want to target, let's do 14 here now, but at up to, let's say up to 30, we keep this to 10, and maybe right off the hit, keep that at 8, and then that will give him a little bit of wiggle room. And obviously, we don't like this super big transition here. So that should do a little bit of good as far as a rudimentary form of traction control. Yep. Once he gets over about 40, start adding all the boosts that we want, and as time goes by, we'll continue to increase this value. Okay, I know this video is really long, and we might split this up into several sections, but I hate when everybody's like, oh, we're going to do this and that, and then they never actually do it, or they don't film it at least. So we're going to take this kind of to the end. So we've been slowly adding some duty cycle to the boost control here. We are hitting 15 PSI near red line, a little touch more. I'm targeting 16 right now, so it's a little bit lower than expected. It is also adding 8.2% of boost control to the short-term trim on that, so that's definitely probably needs about 10% more to reach that 15 pounds, 16 pounds. I'm also starting to add a little bit more boost in the upper RPM just because this car drops off in the upper RPM. So running a little more boost past peak torque should not be knock prone, but will let it make a little more power a little bit longer. So let's take a look at our fueling. You can see here we are targeting a fairly rich lambda here for pump gasoline. I read this in AFR, but it's still called target lambda in the ECU nomenclature. So we are about 4% rich here yet, and the ECU is removing 5%. So if I remove 4% from this area, we're going to be just about right, where I like to see the ECU pulling out a few percent, 5% out of what we're doing here. So let's go look. We're at 7,015 pounds. So we change windows here. We'll go to our closest to our 15-pound row here, and we'll go up to 7,000. And we might as well go above because it's not going to get any better as the RPM gets past the efficiency point. So we're going to go ahead and take out 5% there. Okay. And let's go look at our log again for some more data. So if we look at 6,500, we're actually pretty much perfect. So that's the short-term fuel trims are removing 3%. So we can take a little bit of percentage out of there, but I mean, that's just perfect. I wouldn't worry about it. The only reason I kind of want to take a little bit out of here is I want to make sure that we have a smooth transition. So we'll take 2% out of there, kind of split the difference. Go back to our log. We'll go down to 6,000. Once again, our AFR is reaching commanded. You can tell by this line, except maybe here a little bit we need to focus on. It's doing exactly what we want, but it is removing 3%, which is totally fine. So I'm not even going to change that area. So if we go down to 5,500, same story. It's actually just a little bit, I mean, not really. It's pretty much perfect. ECU is just pulling a little bit of fuel out. You can't expect this to be any closer than a tenth or so. And it's not that desirable for it to be so don't drive yourself crazy with that. So we'll go down to 5,000. And once again, we're just a touch lean here, but nothing that's going to hurt anything. That's also partially why I aim for 11 instead of 1150, because if we're a little off, it's still going to be perfectly safe. The ECU is pulling 5% out, so we kind of need to shimmy down this pull a little bit and see what encouraged it to do that. And then if we fix that, it won't pull this 5% out, and then this will be correct. So a change to the fuel map in this case would not be the right move. So let's go down to 4,500. Same thing here. Still pulling some fuel, but we're really, really, really close. If we go down to lower and lower, we're getting there. And so we're down to 4,000 and we're pretty much perfect, which you can see it is removing some fuel, which we're probably getting from this area here we need to focus on. So rather than attempting to correct this and fight the short-term fuel trims, we want to correct what got it into this thought process that it needs to pull some fuel out, because there is some delay. It's actually a setting in here. I think I currently have it set to about 0.9 seconds before it starts kicking in, and so your short-term trims are always going to run just a little bit behind the actual running conditions. And again, because your oxygen sensor is reading stuff after it's already happened, there's going to be some delay there too, no matter what you do. So let's go look at the 3,500 area. At 3,512 pounds, we're actually quite rich. And that's probably, again, why it's hanging out this -5. And it's just not seeing enough need to change it when it gets to this area because it's pretty close. So if we start to correct this, that would fix that. I'm a little surprised it's doing that. Part of that, again, is you have some wall wetting going on as the boost increases and it's spraying more fuel. It's kind of like acceleration. And that could be part of that, but I can kind of feel this in the car too. It feels slow in this area. So I do believe the data here that's being presented. So you can see here, this is almost 10% rich, even up till about 4,000. So 4,013 pounds. The ECU is taking 6% out just to hit the target. So I'm probably going to take about 5% out of that region. So if we go to 4,012 pounds in our NSP software, and again, there's not a lot of reason to believe that the 14 pound is going to behave much differently. So I'm going to go ahead and take 5% out of that, which most likely means we're going to need to take a little bit out of that. So let's kind of split the difference. We could do a vertical interpolation, however you want to do that. So we'll chunk on down to 3,500. This is much worse. And again, we really should be getting out of the acceleration fueling at this point, but it could be a function of too much acceleration fueling. Let's take a look at what our acceleration fueling is right now. The Haltech calls that transition throttle. Transition throttle enrichment amount here. So it is adding some transitional enrichment here. So honestly, rather than changing this area, because I feel like it makes sense in the map, it might be a touch rich. So let's take a two-pronged approach to this. Let's go look at our, I messed up again, sorry guys. I'm looking at this area in the log. We do have some acceleration enrichment here we need to account for. So I think it has too much acceleration enrichment and the fuel might be a little bit rich. So if we look at our 3,500 area, see there is quite a lump here. I'm going to go ahead and remove 5% here. And we're going to go down a row as well. And we're going to remove 3% here to kind of smooth that together. And of course, we will probably do that same sort of thing to the adjacent areas, because again, there's no reason that this shouldn't act the same in adjacent areas of boost. Okay, so that'll help with that. Okay, so to help have less of this being a problem here at the lower RPM, we're going to take a little bit out of the sync amount for the lower RPM. It's probably all a little bit high, so let's start with that. So I'm going to remove 10% of all of that, and then below here, we're going to remove another 10%. And then we'll go ahead and smooth this, and we'll see how that reacts when we go to drive the car. Okay, so finally we're going to make a few more changes to the boost control. Like see here, we're running 15 pounds. So we are not quite achieving the boost that we run here. We're trying to run 16 pounds at red line. We're running 15. It is adding a short-term trim to that of 8%. So I'm going to go ahead and add 10% to that. So if we go to our boost control under engine functions, first of all, we want to check out our long-term trims. See here, it's not really done anything yet. So we'll go to our base duty cycle. At 15 pounds, this needs about 10% more duty cycle. So we're trying to output about 10% more. So let's go ahead and add 10% there. So that's only going to be, yeah, it's about 3% more there. Okay, so we want to add 8 points to this, basically, not necessarily 8% of this value. That's not going to be enough. So we currently only know what it's like at red line here. but let's go ahead and start there. So we want to add to these, increase. I'm just going to go ahead and switch these to 43. Okay. Now we're going to go look at our deal again, our pull, and we'll go down to 6,000 at 14 pounds. I'm commanding 15, so it's not quite hitting it. Our short-term trend is 6%, so I'm going to add another 8. Let's go a little higher than that at 6,000. Okay. And then we're going to go ahead and go down to 5,000. And we're hitting 14, so we're not quite there either. It's currently adding 3%, which is clearly not enough. I'm going to go ahead and add 6. Still might need more, but we'll start carefully. So we'll change this to 40. No, I think I'll do 41. Okay. Back to here. Let's check it out at 4,000. At 4,000, we're only at 13, so that's pretty far off. It's starting to add some, but it hasn't been in the pull long enough probably to think it needs to. So we're going to go ahead and add a good amount to that. So I'm just going to go ahead and make that the same from there and there. Okay, so that should be pretty good, but obviously if it takes 43% to do 15.9, higher than that is going to take more than that. So let's get this up to 45, a little bit less there, and that should try to do what we're looking for. And I suspect this row is a little bit low as well. So we're going to do that. And that's probably going to be a lot closer. Okay, so this is about the final part on this stage of tuning this 94 3000 GT twin turbo front wheel drive setup. And I'm pleased to say we've gotten a really solid tune on this unit. And just wanted to go over that with you. So if we look at our data log, we did a nice third gear pull here. I'll go ahead and attempt to highlight this and zoom in, and we can kind of see what's going on here. So if we look at the red line here, about 7,000, we are targeting 16 pounds of boost, and we are hitting 15.6 to 15.7 here. So we are extremely close on the boost control. What I did was we see down here, it's attempting to add a little bit to that to make that up. So I added a little bit to the boost control. Duty cycle, which is under boost control base duty cycle. So the ECU will, of course, trim this out, but you do need to get these relatively in the ballpark, unless you're just going to do millions of pulls until the system builds a long-term trim table, which again you don't want to rely on. So you can see here it's added a little bit to there already, but that 1 point definitely doesn't scare me. If this was like 20, then you need to put a little work into your base duty cycles. So if we compare this to our previous map before we did these changes, this is the map. We're comparing it to the map we were running. You can see here for the 15-pound range, I've added 4 to 5%, which is exactly what the log's calling for. The computer was adding 6%, and we were just shy of the target. So it probably needs 8 or 9%, but that'll get it so close that I think we're going to be right on target with that. And boost control is a little bit opposite. If the boost control trims are doing anything, I would like them to add a little bit. A couple percent is fine, 5%. Start getting more than that, then you need to work on your map. That's just the way it is. That way, if that map gets faulted out and doesn't fly anymore, then your boost will just be lower than it needs to be instead of too high. So I would not run around with your boost trims at negative value in the long-term trim table. You can see here also our AFRs are finally getting very close. We were running without an AIT sensor because we had a defective one. And we put a new AIT sensor in it from Haltech, and it made the tune go quite rich, which I thought was interesting because I had zeroed out all the corrections for that. So there must be some other uh, part of the calibration that I'm missing that was affecting that, because it went 10 to 12% rich, which we've tuned out before we did this pull. So that was really easy to correct, but definitely something to keep in mind in the future. Obviously, if you're changing the sensors on your engine, your calibration needs to be validated. But again, that did just surprise me because I intentionally had made the corrections for that zero, and it still seemed to be applying a trim. So this AFR, it's a touch, just a real touch rich. I don't even know that I'm going to change it. Uh, as we get further and further down the RPM, you can see we're high tens, very low 11s type of thing, and the short-term trims are doing almost nothing. So this is very close. The motor's still really quiet. See here, it did increase. We were peaking at about 18 before, and now we're about 19 dB. But there's no sharp spikes in here, nothing related to any particular RPM point. It's just getting louder as it makes a little more power. So our floor for the knock control may actually still be too high. So I do want to address that. So if we look at our knock control down in our engine functionality, let's see here, close my compare mode. Okay, we should have knock control here. Let's see. Knock. So our first of all, we want to look at our long-term trims. Not doing anything there. It's great. We got our knock threshold. So at higher RPM, we're about 25. And kind of as we said, we're only hitting about 19. So I still think this is probably a little bit too high. But let's check some of the lower RPM noise levels as well. So if we look at our pull here, even down here at 3880, it kind of acts the same. We got 16 dB here at 4000. So it's pretty constant noise level, which is encouraging. So about 4000 is doing about 16. So let's go look at this again. So we have our 19 situation here, and then it goes to 20. We're doing about 16. So about all I'm really going to do is decrease this upper level to get that a lot closer to what we're seeing here, in case something goes on with the tune or poor gas gets put into it. We want this, tight enough that he's not encountering it by accident, but not so loose that it's not going to pick up actual detonation events. So I'm pretty happy with this, at least for this particular engine. This engine does have stock pistons. It's been rebuilt, so it's pretty quiet. So if you got a forged piston engine, your values may be significantly different. Just wanted to point that out. So I'm making some changes to this. I'm going to save a new calibration here, but let's go look back at our log. So if we look at our log at 6500, our AFR is perfect. 11 to 1 here, and it's adding just barely any fuel at all, but it's actually a little bit richer than our target, so that doesn't need any changes. So we'll go down to 6,000. We're 100% identical to what we commanded, and it's adding just a touch, which again, that's so little, you're just going to chase your tail starting to fight that sort of thing. Let's see, 5,500, same story. Very, 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 very close to our target. Close enough that we might add 2 or 3% right there. So that's 5,515 pounds. Definitely not a lot to worry about. So let's go look at that. 5,515 pounds. Let's see here. We're just going to bump this up 2%. And you see that lump it made in the map. I told you guys this map was going to be smooth by the time we were done. Just want to do that, and then it's likely to behave in a similar fashion in that RPM range at higher boost as well. Whoops. So we'll just add some fuel, just tiny amounts. If there's any changes I'm even going to have to validate, but just want that to be smooth. Spent a lot of time developing a good map. I'm going to stop now. Yeah. So you can see here, I'm just blending the areas because the engine's VE is more dependent upon the RPM range than it is whether we're running 10 or 15 pounds of boost in this case. So that should fix that. So look back at our map, go down to 5,000. See here, we are 100% perfect. I mean, both banks are completely splitting the difference on this 11-1, and it's only adding 2%. I think we smoothed a little bit of fuel into that, so it's going to be perfect. So 4,500, same story, pretty close for whatever reason. Wideband 1 takes a little lean right there. It's going to be fine. And these AFRs are very conservative anyway, so I could bump this thing up a half point at least and still be safe. So that may just actually be a little bit rich here, and that's fine. That's why we're tuning this car. So that's pretty perfect, but down here we're significantly rich, very, very rich at 3,600. You can kind of still feel that in the car. It's better than it used to be, but it is a little bit rich there. You can feel it kind of bogging down. Down to 3,500. It wants a bit less fuel in the 3,500 region. Oh, I'm sorry, I did not show you my log again. We're just looking at this area here. So if we look at most likely 3,500 is going to be similar. So we're going to take a little bit out of this whole area. And see how that behaves. Just trying to keep the smoothness of this map happy. Over here. There. And bump that back up since we smoothed around it. And that should be okay. Okay. Let's go look at our log. We are checking also for other areas of concern. I've run the car at some differing RPM areas in one of these logs. So let's grab the other log. So if we add a log, second log here, we pulled back from the store. And I did some just some fourth gear kind of cruising holds to validate that sort of thing. Some areas where you wouldn't typically drive, you still want to check out because every little bit of that you improve is going to improve your drivability. So if we look at this one, you can see here we were cruising along at 4,300 for a while. So let's look at that. Okay. Yeah, so that's pretty lean, and you can kind of feel that too. You can see here the ECU is adding all it can to try to help here, but it's not happy. So that's again why you want to run this car, because I was at very, very, very light load at 4,000 RPM in fourth gear, just to get to this part of the map we haven't really seen too much yet. So I mean, because this needs at least 20% basically, probably needs more than that. So let's go look at where that region is. So this is 4,300 minus 8 PSI. I think I lost you on the screenshot again. We went the wrong way with our comparison earlier, so this is going to help that. But that's why I like to compare the previous map, because it's a lot going on. It's easy to miss some things. Better to look at your computer and realize you got a problem than find drivability issues down the road. Okay. And now the map in the low load is starting to resemble the upper loads, which starts to make sense. You can see here we're looking at 0 RPM rising up to close to the peak torque and dropping off. That's how they work, especially stock cams. So we've added probably not enough in this region, so I'm going to add a little more here. And every bit of refinement we do is going to make the car run better. Okay, so that's getting pretty smooth again. So let's validate what we did. So at -9 and 4,000, we added 5%, which is not going to be enough. I'm certain of that. So we're going to grab this bigger area here, add some more fuel to that. And I'm grabbing bigger areas to try to maintain some of the smoothness. And this is a little bit different than OEM calibration. I'm trying to, get as good a gas mileage as possible, but the priority is drivability. So we have slightly different goals here. So if it's a little rich in a couple of spots, that actually hurts your drivability less than being lean. And you can see here, I'm barely taking this. It looks like I'm making a lot of changes, but in terms of actual percentage, it's not much. Okay, so now we're adding 10%. That's probably going to get that happier. Just a little more here. This whole area. Interpolating mentally between the areas. I haven't hit with a log, but can guess what the car is going to want. Right. Still got pretty close to the shape we're looking for. Of course, there's a couple of zags down here that we're probably never going to hit. But let's fix them. Just keep in mind if you start working on the like zero load and 700 or 800 RPM range type of stuff, that is getting into your startup. So if you find the car, you kind of don't want to tune the startup extensively until you've got a good fuel map, because all the startup maps do is corrections and multipliers against your base map. So if your base map is bad and you change it, then it's going to put you back to where your startup's not great anymore. Yep. So, I mean, I tend to do both at once, but if you want to keep things a little simpler, you can kind of just not worry about the startup until the car's tuned as far as drivability and power, and worry about the startup later, but you only get a finite number of attempts to make a car start. And so I like to do what I can while we have a chance. Okay. So let's go see. We've added 12% and 10% at the 4,000 range here at very low load. Let's see what the map wanted. So if we look at 4,000 and -8, the ECU is adding all it could. So we'll be adding another 10% onto that, which will get it close to the range where it can do its thing. I just don't quite trust yet that this actually needs like 25% more fueling there. We're just going to have to find out. So we added enough fuel here that the trims should be able to help us out. And so we'll drive the car again. We'll do an update log. And then if these trims are still 20, obviously we're probably going to chunk in another 10%. But if they're getting down to like 10, then, we'll start doing like 5 or 6 or 8% at a time. Kind of see things. 4,000 and -6 is kind of the same thing. It's super lean. It's adding all that it can. Actually, it just hasn't started the short-term fuel trims yet. That's especially why that's lean. It'll settle in right away. There's delay. So there we got 4,000 and -6. It's kind of adding everything it can. Sorry, I keep missing what window you're on. I'm still not good at OBS. So 4,000 minus 6, we have added 8%, which is at least going to get it a lot closer. I think I'm going to go ahead, though, and add some more to this region. So just don't think that's going to do it. Again, it isn't going to hurt. Okay. Got plenty of room here. And this is sort of the zone of tuning that's not going to be hard on the motor if you make a mistake necessarily, but it is going to possibly make it not drive so nice. Trying to achieve OE plus drivability. And takes a little effort to do that. Just blending these tables because it probably wants similar things. Should not see a gigantic lump anywhere if you can help it. Okay, so that should help a ton. Hesitant to go much further. It's probably going to be similar down here too. And down here. But it really doesn't matter so much. You're probably impossible to hit this load limit here. It's load cells. Still, why shouldn't we do the best we can with it? Okay. Yeah, so I'm pretty happy with that fuel map. Represents the torque curve pretty well. We're going to see how it drives. We basically added just a tiny bit of fuel here, pulled a little bit of fuel out of there, and then we added a lot of fuel where it was really wanting it right there. And so the car should drive pretty dang nice. It was already driving nice, but if you held it at like 4,000, you could feel it was just not happy. You could feel it's not making enough torque. It's kind of rough running. You could see it. So like if you look in these RPM traces, you can see that. Like you can feel that. Okay, that's just the engine just kind of barely running. It just doesn't have AFR it needs to run properly. It doesn't make enough power to hold steady at that point. You can look at some of these areas where it's running better. You can see here are oscillations and the engine speed is not there. I mean, you're always going to see a little bit here and there, but nothing like shouldn't be seeing this jaggy stuff or there's something wrong. Yep, we did a couple of 3/4 throttle pulls here earlier just to validate things, which kind of good we did. Looks like it needs a little bit of fuel here and there. Let's see. So that is 5,509. We need to add, oh wow, we need to add quite a bit there. Let's see what we got going on. And I don't necessarily believe in transitional gear changing is going to be perfect, but because all the delays in the wideband reading. But let's take a look at this. So we were at, I forgot already, scatterbrained. We were at 5,509 pounds. So if we look at 5,509 pound region here, so kind of this area needs a lot, which means this area probably needs a lot, which means this area probably needs a lot. And it's starting to resemble this lower curve we had to increase as well. So this is why you got to drive the car under a ton of conditions. Unless you really got a regimen of testing a whole bunch of various loads. Even dyno tuning isn't going to reveal all this. Whoop, that's definitely not what we want. So it's really best to do some road tuning afterwards anyway. Even if you did get a dyno tune, you're going to want to do that just to prove out drivability. You don't have any of these lean regions here. Part of this is probably because of that AIT effect we were noticing earlier. Yep. There's a few in there. Okay. Yep. No, I don't like this line a whole lot. Smooth that out. There's a hole here. Yep, that should make it a lot happier. Okay, let's go look at our log. This is back into third gear. See here. Uh, this is relatively safe at this low throttle percentage and this low load and things like that, but this is probably a little lean here at 4,210 pounds. So let's see what we did to that versus the previous tune. So at 4,210 pounds, we've added 3%. That's not going to be enough. Okay, let's get that fixed there. Keep that smooth. Okay, getting that curve to it. Kind of looking for, which suggest this might be a little too yet. Okay, and again, we're making relatively tiny changes here at this point. There's also some maps that you can tune different throttle amounts. So you can do like some TPS correction. That may be needed to fix some of these part throttle lean areas. Just have to see. Yeah, pretty lean through here. Same thing here. Very, very, very lean there. So I think we addressed some of these spots. So that's 3 pounds. So at 3 pounds and like 4,000 or so, we did add about 10% there. So we'll just kind of have to take our time because that's a first gear pull. So stuff's going by so fast. Can't necessarily trust out the numbers perfectly. It's right here, but we'll get that a lot closer. 500, 9 pounds. Yep, very lean there yet. Fix that though, or at least we addressed it a little. So 5,500 and 9 pounds, 6%. That's just not going to be enough. 500 and 6 pounds, 9 pounds area here. Just add a good amount of fuel to some of these sections just to be safe here. Should help. Okay, that should be getting up. Kind of lump we expect. Okay. So we added a lot of fuel in some of those low load areas. So that's going to be 5,010 pounds. We added 8%. Let's change that to 10. Maybe the same thing here to kind of back that up. Okay, it's 10%. That's a bit much. Yep. Yep. Okay. So that should help our drivability quite a bit. Nothing's bad now. Okay. I don't really see too much else super concerning. Uh, this is fine. That should really help with the gear-to-gear things. For instance, 4,000 pre-low load, 70% throttle. I think we added about 10 to 15% there. 7,009 pounds. Or sorry, 4,000. Yeah, so that needs a little more yet. Long way with that. Easily fixed. Just blend everything together. I feel like Bob Ross right now. For some reason, just this little tree. Just getting our little fuel map corrected here. Probably needs less fuel as the boost really starts to ramp up and the throttle starts to ramp up, just because our overall efficiency is going to be restricted by the turbos a bit. So you can see that a little bit. That should help a ton. Okay, anything else worth addressing? Let's see. Let's look at our start. Started up very hot. And it immediately got to our target AFR. It's removing some fuel. That's okay. It's going to do that when it first starts and it's hot, most likely. We see that it returns to idle. End of our log here. You can see, we're still a little rich. Okay. So it could possibly use a little bit less fuel. At idle, sitting still on a startup on a cold day, this is correct, but when the engine bay really gets heat soaked, it's probably needing a little bit less fuel here. We can probably, I'm sorry, I did it again. There's our log here. So we're maximum short-term fuel trim being pulled out here. It's targeting a little rich here for some reason, but it's fine. We just probably need to take a little fuel out of there. But let's do that a little bit differently. So rather than changing our base map here, let me close our comparator. I want to go to our AIT settings. So if we go to our fuel corrections and our air temp correction, we do have a manifold pressure versus intake air temperature correction. Let's take a look and see what our air intake temperatures are. AIT. Intake air temperature. We are at 130. And you're going to see that. I mean, this car has a front mount, but it's 90 something degrees today, and the car's sitting with the sun closed idling in the parking lot a lot. Going to see that. So my guess is there's very little correction at that high temperature. Let's take a look. Yeah, so we're 130. Okay, so it's removing 3% fuel. We are in the load region of, let's see, we're in the load region of minus 9.3 pounds, which is going to be between minus 7 and minus 14. So I don't like that a lot. Let's insert a column and put that at minus 9 pounds. Okay. And at 140 here at low load like this, I wouldn't just blanket do this at full throttle, but let's take out some more fuel here. So it's going to pull out 4 more percent. I think it's going to need more. Let's go to 8. And then obviously we're going to want to smooth that out a bit. And just these low loads. So probably this needs a little bit here too. And as it gets even hotter at low load, just kind of build a wall around that. Hopefully we're not seeing any IATs like that. But yeah, so we'll see if that improves our idle trims. Yeah. And you can smooth this map out too, but it's not quite as critical. It's not like you're rolling through these values as it goes. But it probably does need similar stuff there. It's just at higher loads. I don't want to change it that much. See that. It's really hot. Hopefully we're not getting that hot. Yep, let's see how that does. So that kind of wraps it up for this base tune here on this car here. Do not try to copy this fuel map. Okay. Yeah, the shape might be similar to what you got, but you need to tune the car and figure out what your car wants. Um, and just go from there. And it takes quite a bit of work. Obviously, there's a lot of steps in here I could do quicker rather than just sneaking up on things. It would have saved a few pulls to have the AIT in from the start. Um, but here we are, and I'm sure the client's going to be really pleased with the way this runs. We're running 16 pounds with no knock and good timing, and the car feels pretty quick. So I think in the future, he might want to turn the boost up a little bit more. There's a car show this weekend, so I don't want to push it right now. Might get the car on a dyno and see what it likes, but it could use a little bit more boost probably. He also wants to go to a flex fuel setup in the future, which we can tune for him. And, then we're talking 20, 22 pounds type of situation. His car's probably going to pick up 70, 80, 90 horse. It'd be pretty significant on E85. And the extra cooling effects of the 85 would help a lot too. So I hope this has been entertainable. I know it's a lot to digest, and I'm probably going to edit down a lot of this because some of these pools we just kind of go over the same things over and over. I'm sure you're not interested in it, but I'm also going to try to put bookmarks in it too. So I hope that's helpful. If you need help getting any Haltech parts, see us at revengeperformance.com or our sister site partslegion.com, where we have 600,000 parts for all kinds of makes and models. If you need your Haltech tuned, reach out to us. We're starting to do that along with our full car builds and our drivetrain rebuilds, particularly for the 3000 GT and Dodge Stealth. And this has been Chris. Hope you enjoy.